Okay, so now we're on page 81 of your workbook, 7.4 Payout Annuities. So you'll want to check out how this formula was derived. Maybe you don't need to. On page 263 in your textbook, you can read more details about it, but here's the short version. Payout annuity is an account with principal starting amount where money withdrawals are taken on a regular basis. So it's kind of like you set something up like a trust fund, or, well, yeah, so many of us have those, I'm sure, but something like that. You just a retirement that you want to be able to pull money out of. And it will earn interest as you're going, so you don't have to put in as much as you'll actually need. These are, here's an example here for retirement, $500,000, and you want to take money out of the account each month for 20 years so that you have kind of like a salary remaining. So this formula is a little bit different. Just to note a few things, you still have the same letters and variables that are, that are the variables that are equal to the same things, except here we have P sub 0, again, because we have that is an amount we have now that we're pulling out of, not something we're saving up for. So that's the big difference there. So I'm going to work through the problems. I'm going to use an extra sheet for this one because I'll need lots of room. You don't necessarily need to type up, write up all the things that I'm going to write, but I want you to see how it maps up and matches to your calculator and how you key it in. I'm actually going to do this a little bit differently this time. I want you to try them both as classwork. I'll show you the answer first so that you can know if you're right. And if you're right at this point, I feel like you can just move on. You don't have to, you can just leave what you have written there. You got the right answer. Even if you did it a little bit differently than me, you don't need to go through all the calculator motions and things. And you will see the steps, full steps on the solutions anyway. So I'm going to just jot down the answers and hopefully it will all match up. Again, if there's something like you're just really not matching up, you don't know why, how I got the answer, maybe I made a mistake. I don't have an editor for these, so this isn't there's no answer key for this. So I could have possibly made an error on these sometimes. So I'm going to just put the money amount down here. The answer should be P sub 0 equal to $136,869.57 is what should be invested or deposited now. And then you can pull out of that for, I think this one's every year. So your K is just one. So that one's a pretty easy one to work. But that's the lump sum that you need to put in the bank, and then you'll be able to pull out monthly payments of the D is not monthly, but yearly for this one. The next problem is we're finding how much I'll be able to take out if I put that $500,000 in there. So on this one we have, it's provided each month will be the deposits, which are actually withdrawals that you'll be able to make. So even though it's D for deposits, it could be W just as easily. So the answer for that one is your D is going to equal $4,387.86 per month. Okay, so go ahead and try those. I'll pause the video here, you pause it, and then I'll write them up and walk through the calculator work. But if you have both of these answers correct when you're done, you might want to jot them down, then you can just move on. if you're getting a mismatch, please email me right away so we can double check. Okay, so here are the answers all done out for you. What I did for this first one is I typed in 0.065 plus 1, the divided by 1 there, we don't need to worry about. I'm going to put the light up a little so you can see what I'm typing in the calculator a little better. It'll fade the words out, but so here we have, I would just type it in like this, 0.065, and then plus my 1. Don't forget to do that. So I get 1.065. Then I want to raise to the negative 35 times 1. Be careful of that. So you're going to hit the exponent key there to raise it up, the caret it's called, and then hit your negative symbol down at the bottom. Don't use the subtract, it won't work. You need to use the negative. So if you were getting an error, that's why. Then we're going to hit equals, and I get 0.1103, so on and so forth. So then now I will want to subtract all that from 1. Don't just hit minus 1. That was the other formula, so you can't mix and match them that way. So I'm going to go 1 minus the answer that I have here is what I'm looking to subtract off. So I'm going to click down the bottom, that answer key down here. Anything in green, you have to hit that second key first. So then I get 0.889, so on and so forth. And now all that times the 10,000. And then I want to divide by 0.065. And I get $136,869.57 when I round to dollars and cents. And then again, answer in a sentence. That's what he should deposit now in order to have that. You don't need to be too elaborate in your sentences. Just give it some meaning and context. So now this one, we already established the answer before, but that's what he'll be able to withdraw each month. So we're going to now type in all the stuff you need for this one. So I would start here, 0.1 divided by the 12. Add my 1, don't forget to do that. Raise it up to the negative, and then I'm going to use my parentheses, 30 times 12, which you could do in your head instead if you want. And now once I get that 0.05, so on and so forth, again, be careful not to just subtract 1. That's the other formula we had. So you would want to just hit 1 and then minus, second answer, enter, and you get this 0.9495, so on and so forth. Then I'm solving for D's, so I have to just figure out what times D first. So I'm going to divide by the 0.1 divided by 12, but I should use parentheses here, so I'm going to go back. So if you ever miss something, just go back and insert it. You don't have to clear it out and redo it. So 0.1 divided by 12, and then close my parentheses, hit enter, and I get 113. And then I need to divide both sides by that. So the 500,000. Make sure I have all my zeros and not too many. And then divide by second answer, enter. And I get the $4,387.86. That's quite a bit. That's really good. You put in $500,000, but that interest is really high interest rate, so it works really great for that. I'm gonna fix the lights now. So I hope that's helping with the calculator things. If you have any other issues, if you keep getting an error symbol, I can maybe do a calculator tutorial or find one to post. But if you have specific questions, just let me know. And we'll pause there and go on to the next one. Okay, so this is page 82 in your workbook. This is really the same exact formula we had a moment ago in 7.4, except it's loans, amortized loans or installment loans. So instead of having money in the bank where we've been drawing out of it and benefiting that way, we are buying something now, but we didn't pay for it in full. And so we need to pay interest on that. So it's like a car loan, and amortized means they're trying to kill the debt, kill the loan. So we need to pay that off. And this is kind of nice to be able to see how much, if you buy a house or a car, how much extra in interest you're really paying. So you do want to be careful of those things, and the more cash you can put down, if possible, the better. So here's just some little notes to help you keep track of which problems are which type. This example, I think, is pretty straightforward, 7.10, so I'm going to leave that one as just a straight up classwork, and you can check the answer, make sure you're right. That one should come out to be $12,625.50 is part A. That's how expensive a car she can afford. So you'll work out all those details. The total amount including interest is how much in total payments is she actually making, excuse me. So that's what you're going to figure out here, and we talked about that before with a different problem. So you're going to have to do the D times the N times the K, or vice versa, that's okay. So figure out what that should be. I'll write the answer here. It should be 15,000. And then, but you're going to write out the steps. So even if you type in a calculator, show me a few things, what you're typing in, put the numbers there. And then what is the total interest that Race Car Rita will be paying? So I'll write you a little formula here. Total interest, it's kind of reverse what we were doing in the previous section there with the annuities, the future value. So this one is going to be your total payments minus the car cost, or the value, like what she's supposedly paying, and that should come out to be $2,374.50, like extra as opposed to if she paid cash. So try those, pause the video, I'd just get them done right now, and then you can see the full solutions done up. If you're stuck, you can use the forms or ask me a question on those. This one here, Lazy Daisy purchased $300,000 house with 10% down, so that's important because our loan is not going to be on the full thing. She financed the rest at 6% annual interest over 30 years. Okay, so it looks like here that it's just annual interest plus it says over 30 years. It doesn't say that she did anything monthly, which typically mortgages are. So, oh, here it is. What is Lazy Daisy's monthly mortgage payments? So we would want everything to match as we were given that note before. So we are going to have K as 12. So that's our clue right there. And then you're going to have to figure out the total interest you'd pay for the loan. So in order to make sure you start this right, I mean, you could pause it now and just try to do it all on your own and get the answers done up. But I am going to do this one out. But if you are choosing to just want to try it and then move on, the answer for part A, which you're going to get D, is $1,618.79. And the total interest will be $312,764.40 over the life of the loan. That's quite a bit. So, because if she's has to pay that every month, which is pretty typical. This is kind of depressing because it's, I have a house loan. So if you can ever put more money down, that's better. So pause the video. I'll write these up and then show you. I'll just do this 7.11 as an example of video notes. But remember, again, you're supposed to turn in everything that you write, whether you do it along with me with the video or on your own or whatever. Okay, so here's this problem with Lazy Daisy, $300,000 house, and she's putting 10% down. So we want to figure out what she actually is taking the mortgage out on. So if she is putting 10% down, then that means the loan is actually only on 90%. So the easiest way to do this would be to take your 300,000 times 0.9. That's 90% of the loan, and so she has, so that P sub 0 is going to be 270,000. So go ahead and fill that in and see if you can fill in the rest of it. We have D is what we're trying to find, those monthly payments. And then 1 minus 1 plus 0.06 is our annual interest, but we're looking at the periodic interest. It has to be divided by 12. Then we have, remember, it's a negative exponent on these. And you have 30 times 12 months. 30 years, 12 months, and then we divide by 0.06 over 12. So calculating that out, I'll just walk you through on the calculator to the final answer, and then when you see the solutions, I'll write that up as well. So here, I need to shift this over. So here we have 0.06 divided by 12. And then don't forget to add that 1. And then raise it up to the negative parentheses 30 times 12, or just do it in your head. So I get 0.16604. Then I need, that's what all this is equal to, so now I need to subtract that from 1, so I'm going to do 1 minus second, oops, delete that, second answer. So we have 0.83395 for this value, and now we're going to divide all that by the 0.06. Use parentheses, divided by 12. So I have $166 and so on and so forth. Now I need to take and divide the 270,000 by that number. So I'm just going to go ahead and type in the 270,000. Double check. Divided by second answer. See how I'm not rounding. And I get this $1,600.18, $1,600 $118.79 is what we'll round to. So then to figure out the last bit, now I am going to clear it out because I'm just going to use my rounded number. There'll be a little bit of build up with just a tiny bit, but that's okay for this part. So your total payments, remember before we kind of had that in 2 steps, so we take the value, the D that we found, multiply by the number of years times K, and that should come out to be $582,764.40. Just double check that, just type it right in there. If you wanted to leave that number in there before and use it, that's fine. That's 12. Okay, so we're on the same page there. And then now we're going to take that number, I'll leave that right there. And so my total interest, or my total payments, minus the loan amount, the piece at 0. So that is going to be minus the $270,000, and I get $312,764.40. Quite a bit. So, of course, you would surround these with a sentence. I'll write that up in the solutions, but just put some context around it. And do make sure you're checking your solutions and things like that too, as you know, on the next page. Just make sure it all is looking good. So thanks for watching. I hope that was helpful. Have a great day.